Hey, what's up, everyone? We are back doing another live stream going through the Elixir's Getting Started guide. And today we are doing binaries, strings, and char lists. So this will be a fun one. And this is a pretty like macro overview as we run through it. So if you want to learn more as we go through and touch on binaries and bit strings, I linked two videos that I did in my Elixir Basics playlist that dives into bit strings a little deeper and binaries as well. But we'll touch on them. We'll touch on them enough with the getting started guide. I think it'll be a fun video today. So with that being said, let's get right into it. I'm going to open up Firefox. Hey, Daniel. Awesome. I'm glad you're here, man. So let's go ahead and go to elixir-lang.org and go over to guides. And today we are already down to binaries, strings, and char lists. All right. So in basic types, we learned a bit about strings, and we used the isBinary arity1 function for checks. So if you remember, we used the isBinary function and passed a string in, and it would return true to us. Let's go ahead and open up our terminal and start the IEX shell. And so if we do that again, if we do is binary and we pass a string in, we get true back. And so we did this in one of the first videos, I think. Introduction. So our second stream. Okay. So in this chapter, we will gain clarity on what exactly binaries are, how they relate to strings, and what single quoted values like this mean in Elixir. Although strings are one of the most common data types in computer languages, they are subtly complex and are often misunderstood. To understand strings in Elixir, we have to educate ourselves about Unicode and character encodings, specifically the UTF-8 encoding. Unicode and code points. In order to facilitate meaningful communication between computers across multiple languages, a standard is required so that the ones and zeros on one machine mean the same thing when they are transmitted to another. The Unicode standard acts as an official registry of virtually all the characters we know. This includes characters from classical and historical texts, emojis, and formatting and control characters as well. So Unicode organizes all the characters and its repertoire into code charts, and each character is given a unique numerical index. This numerical index is known as a code point. In Elixir, you can use the question mark in front of a character literal to reveal its code point. So if we pull up our terminal here, I also apologize if I sniffle. I got knocked down with a cold yesterday, and I think I almost have it kicked, but it's still hanging around with that congestion. So if we go ahead and do the question mark and then a character A, it's going to return the code point 97. So that's pretty cool. And then we can do this with any character. Let's see if I can type this elk. I have no idea how to type. I don't know how to do that special character, but you can do any character and you get the code point equivalent back to it. I wonder if I can just copy and paste this thing. There we go. And then we can get that code point back as well. So note that most Unicode charts will refer to a code point by its hexadecimal representation. So for example, we get our code point 97 back. That translates to the hex value 0061. And we can represent any Unicode character in an Elixir string by using the \u and then four integers after, which is the hex representation of its code point. So you'll see here that if we do in a string \u and then 0061 and then close those double quotes off, it's going to be equal to the string A. All right, and let's see. Let's just do a quick little reminder on how to count in hex. Excel draw. We'll see if I can draw here. Oh, that is bright. How do I put this in dark mode? Oh, saved my eyeballs. All right, and what's a good color to draw on? Oh, blue looks nice. So with hex, so our code point was 97, right? So how does 0061 equal 97? With hex, it's 16 base. So we have 16 raised to the 0, and then that's here. And then here we have 16 raised to the 1 power. And so what we do here is we do 6 times 16 to the 1 plus 1 times 16 to the 0. And this would be 96 plus 1 equals 97. So that's the hex version of our code point. All right, and let's go ahead and continue with our example here. Also, sorry if you can't read my handwriting. I blame being left-handed. So we can also take the we can take the hex form. So 0x0061 is equal to 97. And also that's the same as this. So these are all the same value. All right, they're all equal to the code point 97. All right. UTF-8 and encodings. Now that we understand what the Unicode standard is and what code points are, oh, you know, is this a link? Yes. All right. So if you go to codepoints.net, you can actually look up all the code point standards here, and this is all about the lowercase a, and you can read about it. It was added in 1993. It belongs to the block A, basic Latin, in the basic multilingual plane. This character is a lowercase letter and is mainly used for the Latin script. So that's kind of cool. And then you can see that like the UTF-8 representation is 61. The code point number is 97. And you can see related characters as well. So you can see all the different code points. And you can go ahead and look, we can go to B next. What does home look like? You can search for code points. But yeah, worth checking out. Definitely could be useful. All right, so now that we understand what Unicode standard is and what code points are, we can finally talk about encodings. Whereas the code point is what we store, and encoding deals with how we store it. So encoding is an implementation. In other words, we need a mechanism to convert the code point numbers into bytes so they can be stored in memory, written to disk, etc. So Elixir uses ATF-8 to encode its strings, which means that code points are encoded as a series of 8-bit bytes. UTF-8 is a variable with character encoding that uses 1 to 4 bytes to store each code point. It is capable of encoding all valid Unicode code points. So let's go ahead and see an example here. We will pull up the IEX shell again. So if we go ahead and set a variable to our variable name string, and that is hello, and we'll try to get this accent. I did it. There we go. So we're going to store that to a variable string. And now if we say string.length and we pass in that variable name, hello has 5 letters, right? But if we actually look at the byte size of this string, we're going to get 6 back. And so although the string above has 5 characters, it uses 6 bytes, as 2 bytes are used for the representation of our E with the accent above it. So you have your accent and E, and that takes up 2 bytes. So note, if you're running on Windows, there's a chance your terminal does not use UTF-8 by default. You can change the encoding of your current session by using chcp 65001 before entering the IEX shell. I haven't ran Windows in years, so that's on you Windows users. So besides defining characters, UTF-8 also provides a notion of graphemes. Graphemes may consist of multiple characters that are often perceived as one. So for example, the woman firefighter emoji represented as the combination of 3 characters: the woman emoji, a hidden 0 with joiner, and the fire engine emoji. So as you can see, if we do string.codePoints and pass in the firewoman emoji, we get back a list of the combination characters, so the code points that are representation of this. And then if we use grapheme, we get the same thing back, because Elixir is smart enough to know that it is seen as a single character, and therefore the length is still 1. All right, so let's go ahead and try this stuff out. I'm going to clear this so we're at the top. Now, if I do string.codePoints and we pass in the firefighter emoji, let's see if we can find this. Firefighter. I can't tell which one a girl is. They all look the same. Maybe this one. Just select it. There we go. All right. What on earth? Let's try this again. No, I don't want to use 1Password. I want my firefighter. There we go. I feel like I got to copy and paste because something is being goofy. See, it's adding. There we go. That's fine. Invalid syntax. Oh, I guess I have to finish writing code points. Dude, things are being weird. All right, let's restart the shell. IEX, clear, and I'm going to copy and paste that again. All right, so if we do string.codePoints and pass in that, there we go. So we get our code points, the female emoji with a joiner and the fire truck. So that's cool. And then if we do string.graphemes, and we pass in the same emoji, we get just a single grapheme back, which is the female firefighter. And then we can also do string.length, and instead of getting 3 back, Elixir knows to send us length of 1. All right, so that's cool. Note that if you can't see the emoji above in your terminal, you need to make sure your terminal supports emoji and that you are using a font that can render them. Ooh, good thing it worked for us. Hey, what's up, Victor? Awesome that you're here. All right, although these rules may sound complicated, UTF-8 encoded documents are everywhere. This page itself is encoded in UTF-8. The encoding information is given to your browser, which then knows how to render all the bytes, characters, and graphemes accordingly. If you want to see the exact bytes that a string would be stored in a file, a common trick is to concatenate the null byte to it. So if we wanted to see the binary representation of hello, we can just do the null byte at the end. So let's go ahead and do that. So if we do this, we can do string hello. I'm not going to do the whatever. I don't even know what those letters are called that are in the documentation. But if we concatenate the null byte here like this, we get our binary representation back. So that's H, E, L, L, O, and then 0 for the null that we added. And then we can also use IO inspect to get the same thing back. So IO inspect arity2 takes a string, and then we can also pass in the binaries. So we can pass in the binaries, and then we want it returned as binaries. So we can do that, and we get the same thing. We get the binary representation back of hello. All right, back to the documentation. We are getting a little bit ahead of ourselves. Let's talk about bit strings to learn about what exactly the these are double chevrons, opening and closing double chevrons, also known as the binary or bit string literal. So that's what this is. So the binary or bit string literal constructor means. So let's go ahead and dive into bit strings. And like I said at the beginning of this, I linked a bit string tutorial from my Elixir Basics playlist. So if you want to dive into any of this stuff deeper, I do some cool stuff in that video. I walk through how bit strings work and then try to relate it to like a real example of how you can manipulate and use bit strings in like kind of a real world example. So I would highly recommend checking that out if you want to learn more on this. Is a Polish character. Thanks, Sasha. The only foreign language I know are programming languages and English, and then it's all over my head. So how do you say that character? Like I know, like if you see U with the 2 dots above it, that's like a umlaut. But how do you say that? I wonder, should we ask the internet? I'm going to ask the internet. I'm going to copy that. How to pronounce the mysterious slash is pronounced like an English W, like the word wool. Well, that's not helpful. Okay, this is. Let's see.
W.
All right.
Łódka. Łódka. Ładny. Ładny. Łatwy. Łatwy. Łazienka.
There's my Polish lesson for the day. Thanks, Sasha. All right. Now I forgot what we were doing. Bit strings. All right. So bit strings. Although we have covered code points and UTF-8 encoding, we still need to go a bit deeper into how exactly we store the encoded bytes. And this is where we introduce the bit string. A bit string is a fundamental data type in Elixir denoted with the double chevron. So I keep the bit string literal syntax. A bit string is a contiguous sequence of bits in memory. By default, 8 bits or 1 byte is used to store each number in a bit string, but you can manually specify the number of bits via the type modifier n to denote the size in n bits. So you can use a more verbose declaration, and you can also say size and then open and closing parentheses with n as well. So right here, actually this is we'll just go straight into the Elixir shell. All right. So for size, by default, a bit string is 8 bits, which is 1 byte, which is, a binary value. So by default, if we just do 42 as a value for our bit string, it's equal to 42, and then we do the double colon, so the type modifier, and then size 8. These are the same thing. So they both take up 8 bits. And we can also write this way. So doing size here, it might just kind of make your code clearer sometimes if people aren't familiar with the syntax. It's the same exact thing. So we can also, though, manually override how many bits we want to use in our bit string. So we can do things like this, 3, and then the type modifier, and we can say 4. And then we get this return, so 3 with 4 bits being used. So for example, the decimal number 3, when represented with 4 bits, is base 2. It would be 0011, which is equivalent to the values 0011, each stored using 1 bit. So let's go back to the drawing board. I need to clear this. Yes, just clear. I wish there was a faster way to clear this. So when we do the value 3, like here, for 4 bits, if we were to represent the binary version of this, it would be 0, 0, 1, 1. And if you remember, so binary, this is value 1, this is a value of 2, 4, 8, and so on. So we would add the 2 bits that are on. So that's 2 plus 1. So this equals 3. Okay, and we can also represent this the same way, but so if we were to go back to the Elixir shell, if we represent 3 as 4 separate bits, we could do this. We could do 0, type modifier 1, so it takes up 1 bit, and then we do 0, again 1 bit, and then we do 1 of 1 bit and 1 of 1 bit. This is the same thing as writing 3 as 4 bits. Okay, so we get true back. And what is happening is, actually, if you watch my bit string video, we actually go over this. But what's happening here is when we do this, you can imagine, so we just made 1 bit. So we have 0, and then we had another bit of 0 and another bit of 1 and another bit of 1. It's just concatenating them together. So instead of these being 3 separate bits, when we write it this way, where's our documentation? When we write it this way, so we're just concatenating single bits, and then it gets pushed together into a 4-bit representation of the same thing. So it's kind of like when we're concatenating strings. It's the same concept, but with bits. I don't know if that makes sense. I feel like I ranted, but that's what's happening. So I'm trying to think of a better way to explain this. Maybe an inside joke by Jose, because he lives in Poland. I mean, I'm sure. Well, I think they just like to use examples with like accents and things, because it shows that it takes up a multiple bits in their examples, you know? That's what I would guess. And I think it's a good way to demonstrate it for sure. All right. So I feel like I rambled on this, but hopefully that makes sense. And let's see, any value that exceeds what can be stored by a number of bits provisioned is truncated. So 256 is the max value of a byte. So that's 8 bits in binary. It can only be 256. All right, thanks, Sasha. I'm glad that makes sense. So you can only have 8 bits. And so what happens when you overflow it with 257? Well, everything to the left ends up just getting bumped out. So it truncates. It truncates everything. So imagine taking 8 bits. So you have your binary value of like what, up to 128, and then you double 128 and put it in the ninth. That is going to be 256, and you're going to have 9 bits in a row, but a binary can only be 8. So it gets pushed, it truncates that last or the very left value, and it goes back to 1. So if we pull up our Elixir shell here, that is why we can say that 1 is equal to 257, because 257 is an overflowed binary value. So we lose, let me draw this to make more sense, I think. How do I clear this? Reset canvas. All right, so a binary has 8 values. So we have 1, 2, 4, 8, 16, 32, 64, 128. That's 8. Whoop. Oh no. My iPad got disconnected. Come on, iPad. Sorry, guys, 1 second. I gotta reconnect this dang thing so I can continue drawing. All right, we're back in business. All right, so we have our 1, 2, 3, 4, 5, 6, 7, 8. So we have our 8 values here. Okay, and what the documentation is showing us is if we were to add a 9th bit to this, it overflows. So our 9th bit is actually 256. So if this is on, and then we have this one on for 257, so these are all zeros. Well, a binary can only be the 8 here. So 257 as a binary gets truncated and is the value 1. All right. I hope that makes sense. It can be a little confusing, but I think drawing helps everything. So that's what happens. So here 256 in base 2 with the representation of what I just showed, the 1 and then 7 zeros and a 1. But since we have reserved only 8 bits for its representation, by default, the leftmost bit is ignored and the value becomes truncated to 7 zeros and a 1, or simply 1 in decimal. All right, that was a mouthful. Binaries. So a binary is a bit string where the number of bits is divisible by 8. That means that every binary is a bit string, but not every bit string is a binary. So bit strings don't have to be 8 bits, but binaries do. Well, I should say they have to be divisible by 8. So they would have to be like 8 bits, 16 bits, and so on. So we can use the functions is bitstring arity1 and is binary arity1 to demonstrate this. Whew. All right. So let's go ahead and pull up our Elixir shell again. So we can do things. We can check to say like is bitstring, and we can pass in values like 3 with 4 bits. That is a bit string. That's true. But if we pass the same thing in to is binary, if we do 3 with 4 bits, that's going to be false because 4 is not divisible by 8. And then we can do things like is bit string and pass in 0, 255 and 42. And this is true. And then the same thing is going to be true if we ask it if it's a binary. So that's true. And if you remember, if we don't specify the size of a bit string, by default, it is 8 bits. So each of these variables is being stored in 8 bits. So that means it's not only is it a bit string, it is also a binary. So these are just 3 separate bytes. So what is that? 8, 16. So there's 32 bytes here, or 32 bits and 3 bytes. All right. So that's pretty cool. And then we can also do, if we do pick the size, we can say like is binary, and we can pass in a value of 42 with the size of 16. And this is going to be true as well because 16 is divisible by 8. That would be 2 bytes or 16 bits. All right, so we can also pattern match on binaries and bit strings. So like if you've noticed so far, there's a lot of use of pattern matching in Elixir. It's a very useful thing, right? So let's go ahead and I'm going to clear this so we can see better. So we can do things like this. We can have our bit string of binaries, so 0, 1, and X. And we can say, we can bind the values of 0, 1, and 2. So when we do this, it's going to pattern match the first 2 values. And since they match 0 and 1, now X is equal to 2. So the same, so that's pattern matching for you. And we can also, you can't pattern match though. So we can't do 0, 1, and X and bind. We can't expect it to bind 4 bytes. So we can't do 0, 1, 2, and 3. So we get a match error because the right hand value has more bytes than the left hand. Now note that unless you explicitly use the type modifiers, each entry in the binary pattern is expected to match a single byte, exactly 8 bits. If we want to match on a binary of unknown size, we can use the binary modifier at the end of the pattern. All right, so if let's say we don't know the length of our binary, like in this case, we want to be able to still pattern match another. We want to still be able to pattern match our binaries without knowing the full length. We can do this. We can do 0, 0, 1, X, and then we can do the type modifier binary. And so now it's going to type match, it's going to pattern match any binary that's there. So not only, so it sees 1, 0, and 1, and then if we do 2 and 3, since these are binary values, it will still match. But when we look at X, it's going to be 2 and 3. So it's actually 2 bytes that we're storing in that variable. There are a couple other modifiers that can be useful when doing pattern matches on binaries. The binary-size modifier will match n bytes in a binary. All right. So this is kind of like with head and tail notation of lists, right? So let's go back into our shell. So if we want a pattern match to head, and we want binary dash size. So we want 2 of the bytes to be the head, all right? And then we want the rest to be whatever remaining binary is there. So then we can bind that to 0, 1, 2, and 3. And when we hit enter, now our head is going to be the first 2 bytes. So we're going to get 0 and 1 back. And then the rest will be 2 and 3. But like, let's just redo this and let's just add 4. Now rest would be 2, 3, and 4. So it's head and tail notation, but you're controlling how many bytes we want stored in the head. All right. A string is a UTF-8 encoded binary where the code point for each character is encoded using 1 to 4 bytes. Thus, every string is binary, but due to the UTF-8 standard encoding rules, not every binary is a valid string. All right. So if we say is binary and pass in the string hello, we get a true back. And then we can also say is binary and pass in our binary. We can say 239, 191, 19, and oh, what did I do? Oh, I have a period, not a comma. So that also is a binary. I'm going to clear this. But not just because that binary we just entered, I'm going to pull that back up. Just because this is a binary doesn't mean that that binary is a valid string. So we can do string valid question mark, and we can pass in the same value, 239, 191, 19. So this binary sequence isn't necessarily a string. So that is a false. All right. So now the string concatenation operator is actually a binary concatenation operator as well. Okay. So I kind of touched on this at the beginning, but I feel like I tried to explain it completely wrong. So if you remember, we can concatenate 2 strings with the concatenation operator. So we can do A and then concatenation HA, and then we get aha. So we just combine those 2 things. And we can also do that with binaries. So we can do 0, 1, and then we can concatenate it to another binary of 2 and 3. And then we get 0, 1, 2, and 3. All right, so given that strings are binaries, we can also pattern match on strings. So we can grab the head of banana and have the rest. All right, so let's do this. So we can pattern match to the binary. We can say head, and then we can say the rest, and we have to have our type modifier as binary. So it is expecting more than 1 byte, correct? And then if we bind that to the value banana, B-A-N-A-N-A, there we go. And then our head is going to be 98, which is the code point. So if we say is head equal to the code point B, that is true. And then if we say rest, we get A-N-A-N-A. All right. That's pretty cool. However, remember that binary pattern matching works on bytes. So matching the string like Uber with the multi-byte character won't match on the character. It will match on the first byte of that character. All right, so this is a good one. So u umla. All right, can I type this? All right, so if I do u with the umla over the top, and then we concatenate it to our null binary. All right, we see that, let's see, the umla is actually 2 code points, or the umla u. So we have 195 and 188. All right, so now if we pattern match and say x rest, and then we do the type modifier to binary, and we set that equal to our umla u ber. All right. So now x is not going to be equal to the code point umla u. All right, because let's just see what the rest is. So if you notice, the x is probably just going to be 195, which is the representation of the umla, I believe, not the actual u. And then we have the u ber as the rest. So if we wanted to have the umla u match, we have to actually use the type modifier, and we can do UTF-8 as our type. So we can do this. We can do x and then our type modifier and pass in UTF-8, 8. And then we can say the rest is binary. And we can set that equal to umla u ber. All right. And when we do that, now if we say is x equal to the code point umla u, we get a true. And then the rest is going to be ber. So when we set it to the UTF-8 encoding standard, it knows that umla u is 2 code points. Okay, charlists. Our tour. Let's see if anyone's chatting. All right, so charlists. Our tour of our bit strings, binaries, and strings is nearly complete. But we have one more data type to explain, the char list. A char list is a list of integers where all integers are valid code points. In practice, you will not come across them often, only in specific scenarios such as interfacing with older Erlang libraries that do not accept binaries as arguments. All right, so we kind of touched, I feel like we touched on char lists in the past, but I can't remember. I'm pretty sure we did. So you used to be able to do just a single quote and then a string and a single quote, and that would be char list. But I don't remember which. In a recent Elixir update, they changed it to the C sigil, which is tilde C. So if you do tilde C and then hello, we will get our char list back. Or no, we won't. A char list. Okay, C sigil. C sigil. How do we see our char list? All right. So if we put in the list of code points H, E. All right. So we're going to pass in all the code points to our letters hello. And we get the char list or the char list representation back. All right, so the C sigil will cover sigils in a later chapter, indicates the fact that we are dealing with a char list and not a regular string. So instead of containing bytes, a char list contains integer code points. However, the list is only printed as a sigil if all code points are within the ASCII range. Okay. So hello, I feel like Oh, I see. So since hello, this hello is within the ASCII range, we always will get the C sigil back. That makes sense. And then if we use that Polish W sound, I had to copy and paste this, we are going to get a char list back. So we're going to get the code points to this back in a list. All right, cool. And then we can also check to see, so this is a list, is underscore list, and pass in the char list or the C sigil hello. That is true. All right. So instead of containing bytes, a char list contains integer code points. However, if the list is only printed as a sigil, if all code points are within the ASCII range. Okay. This is done to ease interoperability with Erlang, even though it may lead to some surprising behavior. For example, if you are storing a list of integers that happen to range between 0 and 127, by default, the IEX, the Elixir shell will interpret this as a char list, and it will display corresponding ASCII characters. All right, so that's funny. So if we go ahead and type in, all right, so let's say we have a list of heartbeats per minute equals, and when we pass in our list 99, 97, 116, it's going to return the C sigil cat. So you can always force char lists to be printed in their list representation by calling the inspect arity2 function. So if we wanted heartbeats per minute, we can say inspect, and then we can say heartbeats per minute, and we can say we want a char list as list. And then we get the string representation of our list. All right, so that's cool to know. So we could have done, so we can do this. If we wanted hello, if we wanted the list representation of hello, we could do tilde C or C sigil hello. And there we go. All right, cool. All right. Where were we? Okay. Furthermore, you can convert a char list to a string and back by using toString and toCharList. All right. So we can say toCharList and pass in hello. We get the sigil. We got to do this one. Okay, so there's our char list. And then we can say to string and pass in the same thing. So we would do the C sigil and then the Polish hello, or whatever that word would mean. And we get the string representation back. And then we can also do this with atoms. So we can say to string and pass in the atom hello. And we get a string hello back. And then we can also do this with numbers. So to string, pass in the integer 1, and we get 1 back as a string. All right. The functions above are polymorphic. In other words, they accept many shapes. Not only do they convert char lists to strings and vice versa, they can also convert integers, atoms, and so on. String or binary concatenation uses the concatenation operator, so the less than greater than, but char lists, being lists, use the list concatenation operator, which is the plus plus. All right, so let's try this out. So if we try to do C sigil, this space quotation, and then the concatenation, and then C sigil fails, we get an error because we can't do that, but we can do, since they're two lists, we can do it like that. And then we get our C sigil, this fails back. And then we also can't do this. So we can't do he plus plus, or the list what was it called? The list concatenation operator. And then we can't do LLO. We get an error as well. We have to do the string concatenation operator, or also works with binaries, and then we get hello. All right, so with binaries, strings, and char lists out of the way, it is time to talk about key value data structures. All right, that's cool. So in the next video, in the next live stream, which I think I'll do on Thursday, we will get into keyword lists and maps. So that was fun, guys. Look at that. We learned all about binaries, strings, and char lists. And if you want to do a little deeper dive, I would check out my Elixir Basics playlist, the bit string video and the binary video. They're pretty cool. And thanks, Sasha. It's always awesome having you guys here. Thanks for tuning in. And I will see you guys on Thursday. Oh, and Friday. Friday's a big deal. Elixir Mentor Podcast. I'm live streaming with Jose Valum. And it is the 12th birthday of Elixir. So it's going to be a very exciting podcast or stream. It's going to be really good. So mark your calendars. It's going to be 10 a.m. Mountain Standard Time. And I'm really looking forward to it. So, all right, guys, I will see you guys on Thursday. Thanks a lot for being here.
Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.